Good afternoon, 10th standard. So this is our video on next chapter 3, section A. So the topic covering on this video will be machines and technical terms related to it. Your next video will be on your levers. So what is a machine? So this you have been learning from your 6th standard. The concept of machine, the terminologies associated with has been already taught to you in your 6th standard. But here we will have a recap on them and also include some of the fundamentals with some extra concepts in them. So whatever you have learned has been recapped, plus we have added some more terms with them. So you all know machine is a simple object which makes me to complete my work very easily. Which makes me to complete my work very easily, though it is very simple in shape. So that is why we call as your simple machine. Best example, all these are given here. To pull a bucket of water, to roll a stone, a massive stone, I use a normal rod. You all have a crowbar, spade, all these are your simple machine. Your bottle opener, you all know about this right from your 6th standard. If you have your 6th standard book, you can just go through it. You all know about all these things very clearly. But here we will see, based on some of the terminologies, how I can use my machine in an effective manner. So before going into that, we have to know the functions and the uses of a simple machine. What are the different functions I can get from my simple machine? The functions which it can offer me. So just like how you speak about in your computer, same manner you will also have some functions which can be given to you by your machine. The first one is called as your force multiplier. So force multiplier means my load is big. You all know what you mean by load. So if your load is going to be quite big, it requires more force, but I'm going to apply a less effort, by which I'm able to overcome this a greater load. In that case, it is called as is your force multiplier. Here your machine is acting as a force multiplier. The example again here are: to lift a heavy stone, a spade is used to turn the soil, pulleys are used to lift a heavy load. So all these are the example of your force multiplier. If you want to move or to lift, that's nothing but moving only. If you want to move an object, a very massive load, you apply very small, a little bit of effort. So that is called as is your force multiplier. Next one, changing the point of application of the effort to a convenient point. Changing the point of application of the effort to convenient point. So look at an example here. That is nothing but your bicycle. In your bicycle, you imagine you're going to, what you will do? Generally, we will apply the effort on our pedal. But I'm applying the effort on my pedal, but actually what is moving over there? My rear wheel. So initially I want to move my rear wheel, but where I'm applying my force, that is at my pedal. My effort is nothing but a force which is applied at my pedal. Therefore, the point of application is different. Actually, I wanted to move my rear wheel, but where I'm applying my force, it is at the pedal, by which the point of application is completely changed. In changing the direction of the effort to the convenient direction, now I'm going to change the direction at all. Imagine about your uh, you're going to fetch water from your well. So you'll be using your pulley. So something like this, right? You will be having your well and all. You will have a pulley system. You will use a rope here, and the other end of the rope will be coming in this side. But actually, without this pulley, if I want to fetch my water, I have to apply my effort in which direction? This direction, yes or no? I have to fetch my water at this direction. But what I'm doing, because of this pulley, I'm applying my effort in a downward direction. So this is the example of point of the change in direction of your effort. So this we use in your changing the direction of effort in a convenient direction. So that is example. Next one, for obtaining a gain in speed. By obtaining a gain in speed, we use your pair of scissors. If the blade of the scissors are going to be very bigger enough, you can cut easily using a very small movement. So that is your fourth application. So these are the four different um, uses which you can get from your simple machine. Based on two, we will be classifying, or we will be able to sort out what kind of usage I need from my simple machine. Okay, so based on the two factors, one is your force multiplier and another one is your gain and velocity. The first and the fourth point, I will decide what kind of machine I'm going to use. So based on them, we will decide it. So here we have a simple definition of your machine. So a machine is a device which we can either overcome a large resistive force at some point by applying a small force at a convenient point and at a desired direction. So can you see, this is your second and third point, at a convenient point at a desired direction. So this is your third and fourth point, second and third point which we saw recently before. Yes or no? Second and your third point which we saw recently before. Okay, so a machine is nothing but it is used to overcome your load is nothing but your resistive force, and in order to overcome a force you have to apply another force, the opposing force or a force. So this force we call as your effort. So both your load and effort are nothing but forces. Okay, listen, both your load and effort are nothing but force. So your resistive force is your load and your small force is nothing but your effort. So what we learned in your second and third point, we learned that you can apply at your convenient point and convenient direction. So it has been mentioned here. So now you can all tell together again. So a machine is nothing but which is used to overcome my resistive force, a large resistive force, by using a small force. My resistive force is nothing but my load and my small force is nothing but my effort. So I can apply this effort at any point, convenient point and at convenient direction. So you call this to be as your machine. Listen. So the definition of machine can be written in this way: resistive force, that is your load, and the small force which I'm applying is called as my effort. So this effort can be applied at a convenient point and in a convenient direction. So this you called as your definition of your machine. So now let us go into some of the terminologies which we will be using here. The first one is your mechanical advantage. So okay, before going into it, we have to learn about load and effort. So I told you load is nothing but the resistive force. Imagine you're supposed to lift 100 kg of a goods, something, 100 kg of vegetables. That is your load. Okay, if you want to lift a vegetable which is going to weight, groceries or anything which is going to weight about 100 kg, that we call as your load, opposing force or resistor. Effort, if I want to move this load, I have to apply some small force. That is called as my effort, the force applied on the machine to overcome this. Why I'm using a machine? I want to move this, so therefore I have to apply an opposite of it, which is called as your effort. Now we will go to mechanical advantage. Mechanical advantage is nothing but the ratio of your load by effort. Load by effort. So as I mentioned to you already, depending upon these values I can decide depending upon this ratio, if it is going to be less than 1, greater than 1 or equal to 1, I can define whether my machine is a force multiplier or a gain in speed, or it can change in the direction of effort. These three categories you can define them. So let us see how it works. Now look at here. The first one, mechanical advantage. What is the definition of mechanical advantage? It is load divided by effort. So I'm going to make my load greater than effort. So my load is 5 and my effort is 2. Therefore 5 by 2, it is 2.5. So whenever your mechanical advantage having a ratio greater than 1, you can use that machine as a force multiplier. Force multiplier means it can be used to lift a heavy object by applying a small force. That is what we call as your force multiplier. Next one, if my mechanical advantage is less than 1. So what you have to do, you have to change your load less than your effort. So again an example, 2 by 4. So 0.5 here it acts as your gain in speed. A pair of scissors, or if you're rowing a boat, all these things can be used for your gain in speed. Okay, the next one, if they are going to be equal. Okay, if they are going to be equal, then which means I can change my direction of effort in whichever point. The convenience points can be changed here. So this is what is given in your long paragraph. Okay, you can also note it this inside side by in your book. So the next topic is about your velocity ratio. So velocity ratio, it means it is a ratio of the effort to the load applied, the ratio of the effort to the load applied. Now what is your velocity formula? It is distance by time taken. Yes or no? It is a distance by time taken. So now let us see how it works. Velocity ratio, VR, is nothing but velocity of your effort divided by velocity of your load. Now what is your velocity formula? It is the distance traveled by time taken. Now velocity of my effort, distance traveled by my effort by time. Next one, velocity of your load, distance traveled by the load divided by time. So now you apply this in your first equation. So which is our first equation? This is our first equation. I'm going to apply equation 2 and equation 3. Equation 2 and 3 I'm going to substitute in my first equation. So if I substitute, I will get dE divided by dL, distance traveled by the effort divided by the distance traveled by the load. How much distance I'm going to put my rod, how much distance the load is going to move. Okay, so that is what it literally means by. So the same equations, VE by VL is nothing but DE by DL. Thus the velocity ratio is defined as it is the ratio of the displacement of the effort to the displacement of the load. So displacement means it is moving from one point to another point. So how much I'm going to move my effort, how much my load is going to move, because that is your ultimate aim. You want to move a load from one point to another point, so you have to apply a effort to it. So again we will also have the same thing, velocity ratio less than 1, greater than 1, equal to 1. So first condition, if my velocity ratio is greater than 1, it acts as your force multiplier. So which means distance of the effort should be greater than the distance of your load. If my velocity ratio is less than 1, it's a gain in speed. Velocity ratio is equal to 1, change in direction of your effort. So this thing, right, it's simple max. So all these are your simple max. 5 divided by 2, which is greater than 1. 2 divided by 5, obviously it is less than 1. 2 by 2, it should be equal to 1. So this is your simple math, but these ratios are going to determine what kind of force multiplier we are actually what kind of machine I'm going to use, whether it is a force multiplier or it's a gain in speed or it's just a changing in direction. So I'll decide basically on them. And our next topic will be on the units. I told you whenever we are going to study a physical quantity, we have to study about its unit. Now all these are ratio. Can you see? Here is also it is a ratio. Yes, it's a ratio. So what is distance? SI unit of distance is meter, and below also it is a meter. Yes or no? Now consider this, the distance moved by the effort is 5 meter, the distance moved by the load is 10 meter. So now what will happen? You try to cancel them. So if you cancel them, it will become 1 by 2. Now both of them are same unit, so meter and meter will get cancelled, therefore there is no unit. So your velocity ratio does not have any unit. Now similarly go for your mechanical advantage. I told you both your load and effort are nothing but force. In the starting of the definition of your machines we told Load and effort is nothing but your force. Load is your resistive force or the opposing force, and effort is a small force which I'm going to apply. What is the SI unit of your force? It's nothing but Newton. Therefore, using that, if I use again, they both will get cancelled off, which is nothing but it's a mere number, it does not have any other units. So therefore the SI unit of mechanical advantage and velocity ratio is 0 because it doesn't have any unit. So next one is your work input. Work input. So what is my work input? It's nothing but effort. I'm applying an effort. Okay, what is the idea of your machine? You apply some force in order to move and another force which is so massive for us. So my work input is nothing but my effort. So recollect the formula for your work done. What is your work done formula? Force into displacement. Now work input. I'm applying for which one? Work input. Work is equal to force into displacement. Now my formula is for work input. I told you what is your input energy over here, that is your effort. Therefore effort into the distance moved by effort. Yes or no? The force is nothing but your effort here. Therefore the distance moved by your effort. Now the next one, work output. What is our work output here? Yes, load. Load is nothing but your resistive force into dl. The distance moved by the load into load, and work input is nothing but effort into distance moved by your effort. So work input, the work done on the machine by the effort is called as your work input. So work done formula, force into displacement. The force here is nothing but effort into distance moved by the effort. So next one, work output. Work output means it is the work which we obtain from our machine. The work finally done by the machine is called as your work output. So work done, force into displacement. The force applied here is load and the displacement of your load. Next topic is efficiency. Whenever you buy an object, we'll always try to look for how much work or how fast it can complete my work. Is it a power saving or anything? That is called your efficiency. Whenever you buy something, you look for something which is able to do in a better manner. We'll always try to find which is going to give me better results. So that is called as your efficiency. So efficiency is the ratio of your output towards your input. So a small input, and if I'm going to get a massive output, which means the efficiency is really good. Yes or no? So that is what you called as your efficiency. So efficiency is work output divided by work input. You can also tell your efficiency in terms of percentage. If you want to tell in percentage, you have to multiply by 100. Again, your efficiency does not have any unit. Okay, remember, it does not have any unit. Listen, work done and again work done. Same units, they will cancel out. Therefore, it does not have any units. So till this, I think you people are clear.